Question 1. Solve 5m plus 10 equals 3m plus 30. We move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides, and we usually move plus or minus numbers before multiply or divide numbers. Now this equation here has letters on both sides, so for that approach, solve an equation with letters on both sides. Try to combine the letter terms by moving the smaller letter term first. We've got a 5m and a 3m, so I'll be looking to move the 3m first. These questions go much smoother if you do that, if you focus on moving the smaller letter term first. So to move the 3m, we can consider it to be a positive 3m, so it's effectively plussing on that right hand side. So we'll minus 3m both sides. Then we get to merge or combine those in that first term there. 5m minus 3m will give us 2m. We've still got a plus 10, and on the right hand side the 3m and the minus 3m will kind of disappear or cancel each other out, leaving us with just the 30. Now I've just got a normal everyday two-step equation to solve. We would like to move the numbers away, so let's move the plus 10 by doing the opposite to both sides. We'll minus 10 both sides. On the left hand side, the plus 10 and the minus 10 will cancel each other out, leaving us with 2m. And on the right hand side, we'll just do the calculation. 30 minus 10 is 20. To get the letter totally on its own, we'll have to move that 2 that's multiplying by the m by doing the opposite, which is dividing by 2 on both sides. That'll cancel all the 2's out on the left hand side, leaving us with m, and 20 divided by 2 makes 10. So the big issue there is, what do we do first? We move the smaller letter term first. Question 2. Solve 3p plus 14 equals 6p minus 1. Solve equations. We move all the numbers away from the letter until the letter's on its own. We look to move numbers by doing the opposite operation to both sides. We usually move plus or minus numbers before multiply or divide numbers. Here we have letters on both sides. We have a 3p on the left hand side and a 6p on the right hand side. In that situation, we'd like to try and combine the letters by moving the smaller letter term first. With the 3p and the 6p, the smaller letter term is obviously the 3p. Now you might get the impression that by moving that first, we're actually collecting the p's or the letters on the wrong side, in inverted commas. So it's not really the wrong side. We can fix that right at the end really easily, so don't worry about that. Okay, let's take away 3p both sides. We consider that 3p to be a positive 3p or a plus 3p at the moment. So to do the opposite there, so we can move it, we'll minus 3p both sides. On the left hand side, the 3p and the minus 3p cancel out, leaving us with the 14. And we'll just process the 6p minus 3p, making 3p, and the minus 1 is still there. Okay, we have a two-step equation now. Let's keep moving things away from the letter. To move a minus 1, we'll plus 1 both sides. That on the left-hand side gives us 15. And on the right-hand side, when the 1's cancel out, we'll have 3p. The 3 is multiplying by the p, so to move that, we'll need to divide by 3 both sides. 15 divided by 3 is 5. And we'll be just left with p on the right-hand side when the 3's cancel out. Now 5 equals p can be easily swapped to be p equals 5, and that's why we shouldn't be concerned about which side the letters get collected in the very start of the question. It's more important to move the smaller letter term first. It makes it an easier question for us. So final answer there, p equals 5. Question 3. Solve 5 outside of x plus 4 equals 4 outside of x minus 3. We'll expand the brackets first, then we'll solve normally. 5 times x makes 5x, then 5 times 4 makes 20. On the right hand side, 4 times x makes 4x, and 4 times minus 3 makes minus 12. So we have then to solve this resulting expression, we move all the numbers away from the letter until the letter's on its own. And we look to move numbers by doing the opposite operation to both sides. And we usually move plus or minus numbers before multiply or divide numbers. This expression has letters on both sides, so we'll look to combine the letter terms by moving the smaller letter term first. In this case, the smaller letter term is 4x. So we consider that 4x to be a positive 4x on the right hand side. So to move that, we'll subtract 4x on both sides. So in the first term there, we have 5x minus 4x, leaving us with just x. Plus 20 is still there. And when the 4x and the minus 4x cancel each other out on the right hand side, we'll be left with minus 12. That minus belongs to the 12 and shouldn't be affected by what we're doing to the 4x. Now just to get the letter on its own, we only have to move that plus 20 by doing the opposite of minus 20 both sides. And we'll go straight to x equals minus 32. We have minus 12 minus another 20. That's a number line question. It's not a two minuses make a plus type question. And we get minus 32 there, be careful. So final answer after all those moving parts, x equals minus 32. Question 4. Solve a over 3 plus 3a over 4 equals 2. Now we're going to multiply every term by what I call a magic number. This magic number needs to be something that 3 and 4 both divide into. Now one easy way of, or easy-ish way of finding out what 3 and 4 can both divide into is to multiply 3 and 4 together and get 12. That works well in this case. So we're going to multiply every term by 12. Let's set it out carefully. I've got brackets around it just to separate things here. We're going to multiply the first term by 12, second term by 12, and the last term by 12. Then we're going to do some cancelling. We'll say to ourselves, 3 goes into the bottom once, and into that 12 4 times. In the second term there, we can say 4 goes into the bottom once, and into the 12 3 times. And on the right hand side, it's just 12 times 2, which won't have any cancelling happening there. Now on the first term there, we have a 4 and an a that are multiplying together because the 4 is outside of the bracket there. So we'll have 4a that results from that. In the second term, we have a 3 that's left and a 3a that's left on the top. They'll multiply together to make 9a. And on the right hand side, 12 times 2 is 24. So that's simplified the question dramatically. We've gotten rid of the bottom numbers and we're processing from there. 4a plus 9a on the left hand side makes 13a, and that equals 24. The 13's multiplying by the a, so we'll need to divide by 13 both sides to get the letter on its own. So we'll do that. On the left hand side we'll just get a when the 13's cancel each other out. And on the right hand side, when you've got two numbers, one number dividing into the other, you can put it in fraction form for your answer if you like. You can have 24 over 13 as our final answer and leave it at that. You could type it into your calculator and see if it simplifies, but that one doesn't go down any further. Question 5. Solve 3x is less than 12. We solve inequations like this using the same methods as solving equations, except if you see yourself multiplying or dividing by a negative, the direction of the arrow, the inequality sign, changes. So here we want to get x on its own. The 3 is multiplying by the x, so we're going to divide by 3 both sides. On the left hand side, 3 and divided by 3 goes once or cancels each other out really. Leaves us with the x, and we've got a less than. And on the right hand side we'll just do that calculation. 12 divided by 3 is 4. Now we weren't multiplying or dividing by any negative numbers, so the arrow or the inequality stays in the same direction there. No dramas. So final answer, x is less than 4. Question 6. Solve. M over 4 is greater than 12. We solve inequations using the same methods as solving equations, except if you multiply or divide by a negative, the direction of the inequality sign changes. So to get the letter on its own here, we're going to have to move a 4 that's dividing. The bottom of a fraction divides into the top. So the opposite of dividing by 4 is multiplying by 4. So we'll do that to both sides. On the left hand side, the divide by 4 and the multiply by 4 cancel each other out, leaving us with just the m. And we have a greater than sign, and 12 times 4 makes 48. So here, once again, we're not multiplying or dividing by a negative, so the arrow or the inequality sign just stays in the same direction. Question 7. Solve. 3a plus 2 is less than 14. To solve inequations, we use the same methods as solving equations, but if you multiply or divide by a negative, we'll change the direction of the inequality sign. Right, we want to solve an equation. We move all the numbers away from the letter until the letter's on its own, remember, and we move numbers by doing the opposite operation to both sides. We usually move plus or minus numbers before multiply or divide numbers. In this case, we'll move the plus 2 first, because it's a plus or minus number there. So we move a plus 2 by doing the opposite, which is minus 2 both sides. This is in the interest of getting the letter on its own eventually. So on the left hand side, the plus 2 and the minus 2 will cancel each other out, leaving us with 3a. We have a less than sign, and 14 minus 2 is just 12, as you know. Now, to get the letter on its own totally there, we'll move the 3 that's invisibly multiplying at the moment. We'll divide by 3 both sides. That'll be left with a on the left hand side when the 3's cancel out. We have a less than sign, and 12 divided by 3 is just 4. Once again, we didn't do any multiplying or dividing by negatives, so the arrow stays the same. The less than sign stays as a less than sign there. Question 8. Solve. 7 minus 4c is greater than or equal to minus 17. To solve an equation, we move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides, and we usually move plus or minus numbers before multiply or divide numbers. We solve inequations the same way as we solve equations, except if we multiply or divide by a negative, the direction of the inequality sign changes. Watch for that in this question. Just a hint. Okay, we have a 7 that's a positive 7, so to do the opposite, so we can move that, we will subtract 7 both sides. On the left hand side, the 7 and the minus 7 cancel out, and that minus that you see on the left hand side belongs to the 4c. So careful with him, make sure that minus is still belonging to the 4c, because what we did with the 7 shouldn't affect that minus. That's belonging to the next term across. So we have 4c minus 4c on the left hand side. At the moment we still have a greater than or equal to sign, and then a minus 17 minus another 7. I'd do that carefully on my calculator or on the number line if I were you. It's not one of those that has 2 minuses making a plus. It's starting off at minus 17 on the number line and going 7 more jumps across to the left, ending up with minus 24, so be a bit careful with that one. Now we have a minus 4 that's multiplying by the c. So to move that, we've got to be extra careful. The opposite of multiplying by -4 is dividing by -4. So that's what we do there to move the -4 away from the C. On the left-hand side, that just leaves us with C. Now watch what happens to the inequality sign. Instead of pointing to the right, it points to the left. Why? Because we were watching for multiplying or dividing by a negative, and what did we just do? We divided by a negative number. So that switches the inequality sign, and a minus divided by a minus makes a plus. 24 divided by 4 makes 6, so that's our answer there. C is less than or equal to 6. Interesting one, that one. Watch out for those multiplying or dividing by negatives. Now we have to switch the sign around. Question 9. Graph x is less than or equal to 3 on the number line below. Okay, what we do here, for greater than or equal to, we have a closed circle. See that circle is coloured in dark black there? And if it's greater than or equal to, the arrow goes off to the right. Now, if you look at it, the inequality sign there, the greater than or equal to sign, points to the right anyway, as does the arrow once we graph this. But we haven't got a greater than or equal to situation here, so we'll have to look at the other situation that we have. With a less than or equal to sign, it's got a closed circle because the values are equal to the number involved as well, not just greater than or less than that. And the arrow points to the left, as does the inequality sign. So we can keep that inequality sign pointing left and our graph pointing left here. We'll put that blob on a 3. We'll colour it in because it's a less than or equal to sign, so it needs to be a closed circle. And the arrow just points off to the left. So that'll be our final answer there. You'll get the hang of those the more that you see. But I like the fact that the inequality sign points to the left here, as does the arrow when we're graphing it. And I like to think of the extra line that's under the inequality sign for a less than or equal to as having enough ink to fill in the blob. So instead of being an open circle, it's a closed circle because of the extra line on the inequality sign. So I like to remember it that way. I hope it helps you. Question 10. Graph x is greater than 4 on the number line below. So for greater thans, we have an open circle because it's not greater than or equal to, so it's not equal to the actual value, it's just bigger than that. So it's kind of like skirts around the value and points to the right. You'll notice the arrow and the arrow on the graph that we're going to use and the inequality sign both point off in the same direction. If it was a less than sign, it would be an open circle and the arrow would point to the left. So here we've just got an open circle skirting around the 4 and pointing off to the greater numbers because that's x is greater than 4. So we're sort of asking, where are the values greater than 4? And it's not equal to 4, so we don't have a closed in circle there. So that's our final answer there. A graph with an open circle around 4 and pointing off to the right in this case.